Hello everyone, welcome again to my channel. This time we will be discussing Quarter 2 Week 8's lesson, and our objectives are: illustrate the center radius form of the equation of a circle, and determine the center and radius of a circle given its equation and vice versa. But before that, let us look back to your lesson. Given this illustration, let us find the distance between these two given points. Let us represent the first point as 0.11 and the second point as 0.52. To find its distance, we will use the distance formula. And what is that distance formula? It is defined by the equation d is equal to the square root of the square of the quantity x sub 2 minus x sub 1 plus the square of the quantity y sub 2 minus y sub 1. Now, in this equation, the value of x sub 2 is 5, x sub 1, 1, y sub 2, 2, y sub 1, 1. Substituting these values to the given equation will give us d is equal to the square root of the square of the quantity 5 minus 1 plus the square of the quantity 2 minus 1. Simplifying these expressions inside the radical sign, we will be having d is equal to the square root of 4 squared plus 1 squared. Therefore, d is equal to the square root of 17. Therefore, the distance between 0.11 and 0.52 is square root of 17 units. Now, let's proceed to our lesson. The equation of a circle in standard form or the center radius form. To understand about it, let us have this illustration. Circle A lies on the coordinate plane where the center is at the origin. Let point PXY represent any point on the circle where the center of the circle is the origin with coordinates 0, 0. Segment AP is the radius of the circle, and to find the length of the radius, we will use again the distance formula. Let us represent the first point as point 0, 0 and the second point as point XY. And to find the distance between these 2 points, it is given by the equation the square root of the square of the quantity x sub 2 minus x sub 1 plus the square of the quantity y sub 2 minus y sub 1, which is equal to segment AP. In this equation, the value of x sub 2 is x sub 1, 0, y sub 2, y sub 1, 0. Substituting these values to our equation, we will arrive at the square root of the square of the quantity x minus 0 plus the square of the quantity y minus 0, which is equal to the length of the radius r. Simplifying the expression on the left side of the equation, we will have the square root of x squared plus y squared is equal to r. Squaring both sides of the equation, the result will be x squared plus y squared is equal to r squared, which is the equation of a circle in standard form or the center radius form. Now let us have an example for this topic. What is the equation of the circle with center at the origin and radius of length 8? So the given in the problem are the center, which is at point 0, 0, and the radius of the circle, which is 8 units. Using the center radius form of a circle, x squared plus y squared is equal to r squared, we will replace the variable r with the value of the radius, which is 8 units. So this is equal to x squared plus y squared is equal to 8 squared. Simplifying 8 squared, that is the same now as x squared plus y squared is equal to 64. This is the equation of the circle whose center is at the origin and whose radius is 8 units. What if the center of the circle is not at the origin? What do you think will be the equation of the circle? To know about it, let's proceed to the next topic. The equation of a circle with center HK and the radius R. Given this illustration, let point HK be the center of the circle and the point xy represent any point on the circle, and the radius r. To find again the length of the radius r, we will use the distance formula. Let's represent point HK as our first point and then point XY as our second point. The distance between these 2 points again is defined by the equation the square root of the square of the quantity x sub 2 minus x sub 1 plus the square of the quantity y sub 2 minus y sub 1, which is equal to the length of the radius. Substituting the values for x sub 2, x sub 1, y sub 2, y sub 1 from our given 2 points, that is equal to the square root of the square of the quantity x minus h plus the square of the quantity y minus k is equal to r. If we square both sides of the equation, we will arrive at the square of the quantity x minus h plus the square of the quantity y minus k is equal to r squared. And this is the equation of the circle in standard form with center hk and radius r. Take note, the square of the quantity x minus h plus the square of the quantity y minus k is equal to r squared. Let us have an example for this topic. Find the equation of a circle in standard form whose center is -1, -1, and radius of 4 units. Here is the illustration of the problem. The center of the circle, which is at point -1, -1, and the length of the radius, which is 4 units. On our given problem, the center is at point -1, -1, and the value of the radius r is 4 units. Recall that the standard form of the equation of the circle, wherein the center is not at the origin, is being defined by the square of the quantity x minus h plus the square of the quantity y minus k is equal to r squared. If the center of the circle is not at the origin, so we will be having the point hk. Substituting the value of h and k to our standard form of the equation of the circle, and at the same time the value of r, will arrive at the square of the quantity x minus -1 plus the square of the quantity y minus -1 is equal to 4 squared. Simplifying both sides of the equation, that is the same as the square of the quantity x plus 1 plus the square of the quantity y plus 1 is equal to 4 squared, which is the same as the square of the quantity x plus 1 plus the square of the quantity y plus 1 is equal to 16. Now, aside from the standard form of an equation of a circle, we also have the general form of an equation of a circle. And what about that? So let's discuss this topic. Given the standard form of an equation of a circle, if we expand the first and last term on the left side of the equation, the square of the quantity x minus h is the same as x squared minus 2hx plus h squared. And when we square the quantity y minus k, this is the same as y squared minus 2ky plus k squared. Recall that the square of binomial, the result is a perfect square trinomial. I have a video on squaring a binomial. You may refer that for your reference. Now, if we rewrite the standard form of the equation of a circle in expanded form, this is the same as this equation. And when we transpose r squared to the other side of the equation, or we subtract both sides of the equation by r squared, this is equal to this equation. Okay? And then let -2h equal to d. And then -2k equal to e. And h squared plus k squared minus r squared equal to f. So, rewriting this equation, we will have x squared plus y squared plus dx plus ey plus f is equal to 0. And this is the general form of the equation of a circle. Let us have an example for this topic. Write the equation of a circle in general form with coordinates of the center at point -2, 1 and radius 6. To solve this problem, let us first identify the given. The given are the center, which is at point -2, 1 and the radius, which is 6. Next, recall the standard form of the equation of the circle. Then identify the value of h, and that is -2. Next, the value of k, and that is 1, and the value of r, which is 6. Then, substitute that values to the given standard form of the equation of the circle. After that, you simplify the expression. This is equal to the square of the quantity x plus 2 plus the square of the quantity y minus 1 is equal to 36. Then, if you have observed, we have here binomials being squared. Let us expand those binomials. So, the square of the quantity x plus 2 is equal to x squared plus 4x plus 4. And the square of the quantity y minus 1 is equal to y squared minus 2y plus 1. Again, after rewriting that into the standard form of an equation of a circle, you have to expand or you square the binomial. And this equation is the same as this equation. Then after that, subtract 36 to both sides of the equation, or you transpose 36 to the left side of the equation, and that will be equal to this equation. Then, recall that the general form of the equation of the circle is x squared plus y squared plus dx plus ey plus f is equal to 0. The first term is x squared and the second term is y squared, and that is given on our equation. The third term contains the literal coefficient of x, and that is 4x. The fourth term is the term that contains the variable y, and that is -2y. And f here are the constant term. Let us simplify 4 plus 1 minus 36. Then therefore, this is now equal to x squared plus y squared plus 4x minus 2y minus 31 is equal to 0. So this is the general form of the equation of the circle. Let us reverse the process. This time we will determine the center and radius of the circle given an equation. Example: determine the center and radius of the circle given by the equation x squared plus y squared is equal to 24. So the given equation is x squared plus y squared is equal to 24. Recall that the standard form of an equation of the circle where the center is at the origin, it is in the form of x squared plus y squared is equal to r squared. So meaning to say the center is at point 0, 0 on this equation, but how about its radius? To find the radius, let us equate r squared is equal to 24. Then let us solve for r by extracting square root to both sides of the equation. And then let us factor square root of 24 as the square root of 4 times 6. Then we can now solve for r, which is equal to 2 square root of 6. So therefore, the radius is 2 square root of 6 units. Here is the graph of the circle having an equation of x squared plus y squared is equal to 24 with center at the origin and the radius, which is 2 square root of 6 units. Example number 2. Determine the center and radius of the circle given by the equation the square of the quantity x minus 3 plus the square of the quantity y plus 2 is equal to 49. So this is our given equation. Recall that the standard form of the equation of the circle is the square of the quantity x minus h plus the square of the quantity y minus k is equal to r squared. Because from this, we can easily see the center and the radius of the circle. But let us rewrite first the second expression, y plus 2 into y minus negative 2. And at the same time, 49 into 7 squared. Therefore, we can now identify the center and the radius of the circle. And that is 3, negative 2, and the radius is 7 units. Example number 3. Determine the center and the radius of the circle given by the equation the square of the quantity x plus 1 plus y squared is equal to 64. So here is our given equation. We are going to write this into the standard form of the equation of the circle. And the square of the quantity x plus 1 is the same as the square of the quantity x minus negative 1. And y squared is the same as the square of the quantity y minus 0. 64 is equal to 8 squared. So we can now identify the center and the radius of the circle. And the center is at point negative 1, 0, and the radius is 8 units. Example 4. Determine the center and the radius of the circle given by the equation x squared plus y squared minus 6x minus 135 is equal to 0. How do we determine the center and the radius? Here are the steps. First, add 135 to both sides of the equation. Then, simplify. Group the terms that involving x and y on the left side of the equation, and this is the quantity x squared minus 6x as the first group plus y squared is equal to 135. Then, complete the square in x squared minus 6x, and that is the same as the quantity x squared minus 6x plus 9. And since you have added 9 on the left side of the equation, you are going to add also on the right side of the equation. Then, combine. Then factor x squared minus 6x plus 9, that is equal to the square of the quantity x minus 3 plus y squared, and then on the left side is equal to 144. Can you now identify the center and the radius of the circle based on this equation? Let us check. Let us rewrite first into the standard form of the equation of the circle. Our given equation is the same as the square of the quantity x minus 3 plus the square of the quantity y minus 0 is equal to 12 squared. So, we have now the center which is at point 30 and the radius which is 12 units. Example 5. Determine the equation of the circle whose diameter has its endpoints at point 62 and 410. Let us illustrate the given problem. We have here the circle containing the diameter and its two endpoints. But we are asked to find the equation of this circle. How? Let's start with finding the midpoint of the diameter to find the center of the circle. We will use the midpoint formula to find the midpoint of the diameter. The two given endpoints are point 62 and 410. Let us have x sub 1, y sub 1, and x sub 2, y sub 2. These values will be substituted to the midpoint formula. And that is equal to 6 plus 4 all over 2, 2 plus 10 all over 2. And then therefore, the midpoint of the diameter is 0.56. So, in this illustration, we have now the midpoint of the diameter, which is also the coordinates of the center of the circle. Take note that when we are going to find the equation of the circle, we have to find the center and the radius of the circle. We have already found the center of the circle, but we will look for the length of the radius r. So, to find the length of the radius r, that will be our next step. And we will use the coordinates of the center of the circle and one of the endpoints of the diameter. Let us choose 410. To find the length of the radius r, we will use the distance formula. With these values of x sub 1, y sub 1, x sub 2, y sub 2, substitute that to our given equation, we will have r is equal to the square root of the square of the quantity 4 minus 5 plus the square of the quantity 10 minus 6. Simplifying these expressions, we will have r is equal to the square root of negative 1 squared plus 4 squared. It is equal to the square root of 1 plus 16. And then therefore r is equal to the square root of 17. So we have already the center, which is at 0.56, and the radius, which is square root of 17. So for our third step, we will substitute the values of the center of the circle, which is at 0.56, and the value of r, which is equal to the square root of 17, to the standard form of the equation of the circle. And that is equal to the square of the quantity x minus 5 plus the square of the quantity y minus 6 is equal to the square of square root of 17. Simplifying this expression, we will have the square of the quantity x minus 5 plus the square of the quantity y minus 6 is equal to 17. And this is the equation of the circle. Thank you for watching and learning with me.